Hello, this is a chemistry video on enthalpy. Enthalpy is a topic that you'll come across in any chemistry course. It has to do with either the amount of heat that a reaction absorbs, in which case it's positive because the components are gaining energy, or the amount of heat that a reaction gives off, exothermic, in which case the heat is negative because the system is losing energy. Just as a quick reminder, when a system does work on its surroundings, that's called negative work because the system's not gaining anything, the system's losing. If work is done on the system, that's positive work. Okay, hold that thought. So this is a video on enthalpy, and for the record, we are following the order of topics in Brown, Burston, LeMay, and Murphy's Chemistry, the Central Science. We're in chapter 5 on stoichiometry. Okay, enthalpy. So most chemical reactions take place at constant pressure. We call those isobaric processes. And so the reason why most chemical reactions take place under constant pressure is because, like, if you have a chemical reaction in a beaker, what is the pressure on the top of the beaker? Well, it's the same atmospheric pressure at the beginning and the end of the reaction, right? So most chemical processes are isobaric. They take place at constant pressure, and that's where the concept of enthalpy comes in, because enthalpy assumes constant pressure. Okay, so changes in volume are the main work that is done in these kinds of circumstances. So the book talks about the oxidation of zinc, which gives off gas. If you were to do this in a system where there was say a piston that could expand or contract, what happens is that as the zinc metal dissolves, you find that hydrogen gas is given off, and the piston increases because the volume increases. And so work is done on the outside world, therefore negative work. Remember, the system is selfish. When the selfish gets work, it's positive work. When the selfish does work, it's negative work. Okay, so changes in volume are the main work done in these constant pressure reactions. And the formula for the work done is negative pressure times the change in volume. Okay, the work done is the negative of the pressure times change in volume. In case you doubt me, let me derive this for you real quick. Again, the book does it for you in the box in the middle of this section. But in case you doubt, so work equals force times distance, right? So let's say we have a piston. The work done would be the force on the piston times the change in height of the distance, okay? Work equals force times distance. That's a physics kind of thing. So what is the force on the piston? Well, it's going to be the pressure on a particular area, right? So pressure times the area is the force. So the change in volume is the area times the change in height, right? So we've got the two dimensions of the area and then the third dimension of the height, and that gives us the change in volume. So we put it all together, and what do you got? Well, you've got, so work equals force times distance, right? But force equals PA, so I've substituted in PA for F, and then area times the change in height is the change in volume. So I'm going to substitute that in for A delta H, and so we have, voila, work equals pressure times change in volume, and again, because it's being done on the environment, it's negative. Okay, so that's the derivation of that formula. So let's go back to enthalpy. At constant pressure, enthalpy is simply the amount of heat that is added or taken away from the system. So the next video is going to be on changes, enthalpy. What's the title of the next section? The next section is enthalpies of reaction. Basically, the amount of heat that's either given off or absorbed during a reaction, enthalpies of reaction. So enthalpy is simply the amount of heat that's added or is taken away from the system during a process. And so we can say that the change in enthalpy, which is given the symbol H, by the way, I want that P to be little. So let me do an I Dream a Genie, and the P is little. Okay, so that means the heat added at constant pressure. So the change in enthalpy is simply in a constant pressure environment, the heat added at constant pressure. Okay, so the change in enthalpy is closely related to the change in internal energy. So we know that the change in internal energy equals, in this particular case, the heat at constant pressure plus the work, right? And we've defined, or we can rearrange the symbols around and say that the heat added or subtracted at constant pressure equals the change in energy minus W. I just brought the W to the other side by subtracting it on both sides, okay? So I've got this nice little equation that equates the enthalpy, as it were, to the change in internal energy minus the work. But we know from the previous page that work is negative P delta V. So substituting in, the negative and the negative becomes a positive. And so basically we can say that the change in enthalpy is the change in internal energy plus P times the change in volume. So let's universalize this here. Just as the change in enthalpy equals the change in internal energy plus P delta V, we can say that enthalpy, and this is the general equation for enthalpy, the enthalpy equals the internal energy plus the pressure times the volume. Okay, so there's the formula for enthalpy. Okay, so enthalpy is thus a state function. What's a state function? A state function is a function that it doesn't matter what, I don't care how you get here, just get here if you can. So it doesn't matter how you got there. A state function says the value depends on what state you're at now. So like if I'm going from Florida to Indiana to New York to Florida, my elevation is a state function because it doesn't matter how I got to that elevation. My elevation is my elevation. But the distance I travel is not a state function because I could have gone all kinds of different ways to get there. So internal energy is a state function, pressure is a state function, volume is a state function. What these things are depends on what they are right now. It doesn't matter how you got there. What they are right now is what they are. And so since all of the components of enthalpy are state functions, enthalpy is a state function. The state of the heat depends on the state it's at right now, not where it's been, not where it's going. Okay. Now, because heat is something easy to measure, enthalpy is a more useful concept for chemical reactions than internal energy. Are you going to add up all the little energy, kinetic and potential energies of all the little atoms and molecules in this little lump of something? Well, you'll be there forever, and your children will be there forever, and their children will be there forever. No, but heat added, heat taken, that's easy to measure. So enthalpy is a more useful concept for chemical reactions, especially since they're under constant pressure, like as we said, than internal energy. Okay, some final points in this video. I've already said this, but let's sum it up. H is positive. Enthalpy is positive when heat is added to the system. Remember, the system is selfish. Only when I get something is it positive. You know, so enthalpy is positive if heat is added to it. We call that an endothermic reaction because thermo stuff, heat is going in, endo. It's going endo, okay? On the other hand, H is negative when heat is lost from the system, when it's giving out. Exit, when heat is exiting. Thermo is exiting. I've lost heat. That's negative. Okay, so again, reminders about the signs of enthalpy. Now, just also to say that what we've said here, that what the change of enthalpy is in a chemical reaction basically is what the heat that's either been added or that's been lost at constant pressure. Okay, that's where we started. That's where we'll end up in terms of enthalpy. Reminder from previous stuff, previously on chemistry, that the change in internal energy equals the heat at constant volume because there's no work done. Remember, E equals Q plus W. So at constant volume, no work is done. And so basically the change in internal energy simply equals the heat added or lost at constant volume. So those are some summaries of places that we've been. So this has been an introductory video on enthalpy. More on enthalpy yet to come.